Hello everyone, good day. Welcome to VSPARKZ. In this video, we are going to see the concepts of network namespaces. We are also going to see a demo on the same as well. If you like this video, please subscribe to VSPARKZ channel and click the bell icon for the latest updates. This is the agenda of this video. We are going to discuss on these topics in this video. Linux namespaces. Linux namespaces are the Linux kernel feature with which the containers are actually built on. These namespaces provides a way to isolate independent processes from each other, and it makes them invisible to the rest of the system. These Linux namespaces are used to enforce segregation of resources within a host machine. We will see the different types of namespaces which are supported by Linux kernel and its users. User namespace. User namespace is used to isolate the system user IDs. PID namespace, that is process ID. PID namespace isolates the system processes. Network namespace. Network namespace provides an isolation of host network stack. UTS namespace. UTS namespace isolates the host name. Mount namespace provides an isolation of host file system mount points. IPC namespace. IPC namespace provides an isolation for inter-process communication utilities. Cgroups. Cgroup namespaces helps to limit, account for, and isolate the resource usage for a collection of processes. Resources here refers to CPU, memory, disk IO, network, and so on. With respect to containers, these namespaces are important. That is the PID namespace, network namespace, and Cgroup namespace. Let us see a bit more in detail. Network, PID, and Cgroup namespaces. Network namespaces are a Linux kernel feature which allows us to isolate network stack from the host network. For example, using network namespaces, we can create separate network interfaces, routing tables, and firewall rules which are completely isolated from the base operating system or the host. These network namespaces operate independently. PID namespace. This process ID namespace provides an isolated workspace for a set of processes. These processes will not be available to the rest of the operating system. For example, in this picture, the processes X, Y, Z are the common processes that is running in the Linux operating system, which will be accessible across the operating system. Whereas the processes 1 and 2 are created within the namespace and are not available to the rest of the world. Similarly, the network interfaces, routing tables that are created within the network namespace are not available to the outside world. This indicates that the namespace provides an isolated environment within the OS itself. Cgroup is also a Linux kernel feature that is used to limit, inspect, and account the resource usage for a set of processes. This picture shows how the Cgroups is involved to limit the resources like CPU, memory, and other resources for the processes 1 and 2, which is isolated from the other processes using the PID namespace. Namespaces and containers. Linux namespaces are the base for the container technologies like Docker and Kubernetes. Clubbing all these namespaces together led to the innovation of containers. Every container runs in a separate namespace and its access is limited to that particular namespace. Who manages this container creation and its associated namespaces? It is the container engine or the container runtime that manages these containers. Network namespaces. Now let us discuss about the network namespaces. As you all know that the network namespaces allows the containers to have its own network interfaces, IP addresses, routing tables and so on, which is completely isolated from the host machine. Let us see how to create network namespaces and how the communication happens between the network namespaces. We can simply create a network namespace by simply executing IP netns add command. Similarly, we should create a local virtual bridge in order for the network namespaces to talk to the outside world. By default, the network namespaces has its own loopback interface. So in this picture, we have created red namespace and a blue namespace. Here the virtual bridge is vbridge-1. In order for the namespaces to communicate each other, we need to create virtual interfaces. These virtual interfaces always comes in pairs. Attach one side of the virtual interface to the namespace and the other side to the virtual bridge. We can also attach the interfaces between the red and the blue namespace. If we do so, these red and blue namespace can talk each other, but they cannot reach the outside world. That is why we are connecting it to a bridge network. In order for them to speak with others, they need an IP address. But these IP addresses should not overlap with each other. Once the IP addresses are assigned, we should enable all the interfaces. This should include loopback as well. Now these network namespaces can reach other, but still the outside connectivity is not enabled. This is because the network namespaces don't know about the outside network. In order to do that, we need to add default routes to the network namespace. Also, we need to enable NAT and IP forwarding rules in the local machine, so that the local machine will forward the traffic from the namespace to the outside world. Once all these steps are done, now the namespaces can reach the other networks with the help of its own routing table. How about the communication between the network namespaces that exists in two different nodes? From this picture, do we think that the blue namespace reach green namespace? No, cannot. This is because the blue namespace does not know about the virtual bridge network number 2. Similarly, the green namespace does not know about the virtual bridge network number 1. In order to establish this communication, we need to add the routes in the local machine. For example, in node 1, we need to add a route to reach bridge 2 network, that is 10.10.2.0/24 through the node 2 IP. So we need to add node 2 IP as the default gateway. Similarly, we need to add the routes in node 2 as well to reach virtual bridge network number 1. Once these routes are added in both the sides, blue namespace can reach green namespace. Now we will see a demo on network namespaces. Step number 1. Access the nodes and inspect the existing network setup in Node 1 and Node 2. Node 1 and Node 2 are already connected to a physical network. Just to save the time, we have consolidated all the commands in a notepad, and the same is available in the video description. This is our node 1. IP link command shows the Ethernet interfaces connected to node number 1, whereas the IP ADDR command shows the IP addresses assigned to those interfaces. Here we can see the IP addresses of node number 1, which is 192.168.74.13. Similarly, check the same in node number 2. Node 2's IP is 192.168.74.14. Step number 2. Create network namespaces and a virtual bridge network in node number 1. We are going to create red and blue namespaces in node number 1. We must note that every network namespace will be created with the default loopback interfaces. Now let us create the same in node number 1. If we want to check the interfaces within a network namespace, use ipnetns exec command. Here we can see the default loopback interfaces that is present within the red namespace, but it is in down state. Similarly, check for the blue namespace. Step number 3. Create and attach virtual interfaces or VETH pairs in node number 1. We have to attach one side to the network namespace and the other side to the virtual bridge. Here we are going to create VETH 0-red-in and VETH 0-red-out interface pairs for the red namespace. Similarly for the blue namespace as well. We can have any naming conventions for these pairs. Now we are going to attach one side, that is -in interfaces, to the namespace. Verify the same within the namespace. Now we are going to attach the other side, that is -out interfaces, to the virtual bridge. Cross verify the same as well. Step number 4. Assign IP addresses to the virtual interfaces within the namespace and also to the virtual bridge. We are assigning 10.10.1.0/24 to VETH0-red-in interface, which is connected to the red namespace. Similarly, we are assigning 10.10.1.20/24 to the VETH0-blue-in interface, which is connected to the blue namespace. Finally, assign an IP address to the virtual bridge number 1, which is 10.10.1.1/24. Once the IPs are assigned, it will be reflected within the namespaces and the bridge as well. But still, all the interfaces will be in down state. Step number 5, enable all the virtual interfaces and the loopback interfaces. By default, all the interfaces are in down state, and so we have to enable it. Once you enable the interfaces, the communication between red and blue namespace will get activated. Now we are going to enable all the interfaces. That includes VETH bridge and the loopback as well. Now cross verify the same. We can now see the virtual bridge is up and running. Now test the loopback interface within the namespace. If we get ping response from localhost, then it means that our loopback is working properly. We can see the loopback responses from the red namespace, so which means it is working properly. Now from the red namespace, try to ping blue's IP, which is 10.10.1.20. Yeah, we can able to reach blue namespace from the red namespace. Similarly, test the same from or within the blue namespace. Step number 6, add default routes to the network namespace to reach the outside world. Once you add the routes, namespaces can reach the local node, but it cannot reach the other nodes and networks as the local node did not forward the source traffic. Here, the default gateway for our namespace is going to be the virtual bridge IP, which is 10.10.1.1. This clearly says via the virtual bridge only, the namespaces will talk to the outside world. Once added, try to ping node 1's IP from the blue namespace. Node 1's IP is 192.168.74.13. Here we can see the ping responses from node 1, which means the namespace can reach the base machine now. If you try to ping node 2 from blue namespace, it won't work as node 1 did not forward the source traffic. Step number 7, add IP table rules and forward the host traffic using SNAT, that is masquerading. Once the rules and SNAT is enabled, the traffic from the namespace will reach the other nodes and networks as well. try to ping node number 2 from blue namespace. Node 2's IP is 192.168.74.14. Yeah, it is working now. The blue namespace can also reach to the internet as the physical network has access to the internet. Yeah, you can see the blue namespace can reach to google.com. Step number 8. Repeat the same steps that was done so far in node number 2. Still the communication between the network namespaces in different nodes is not established, since we need to do one more additional configuration, which we will see it in the next step. This is my node number 2. Once all the steps are done, try to ping green namespace from the blue namespace. Both these namespaces are located in different nodes. The green namespace IP address is 10.10.2.30. We won't be getting any responses as we need to route the traffic properly between these namespaces. Step number 9. In order for the namespace to namespace communication in different nodes, we have to add routes in the local machine. In node 1, we have to add a route for 10.10.2.0/24. That is the virtual bridge number 2 network, and the gateway to that route is going to be node 2's IP, which is 192.168.74.14. Similarly, in node 2, we have to give the details of node 1 in the route table. Step number 10. Test the connectivity between the network namespaces in different nodes. Now, in node number 1, ping green namespace IP from the blue namespace. It appears that the firewall D within the Linux machine is blocking the ping request. Similarly, try to ping the blue namespace IP from the green namespace. Here also we are getting the same problem. Now try to disable or stop the firewall D and try for the same. Now we are getting the proper ping responses. This concludes that we are able to reach namespaces which exist in different nodes. Well, that's it for this lecture. This is the summary that we have discussed so far in this video. Thank you from VSPARKZ and thank you for watching this video.